Hello students, in this video we are going to solve this previous year question which was asked in 2012 and 2014. The question is, water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 kilometers per hour. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is needed? Before we start the solution of this question, we must understand this that the question is being distributed in two parts. First part is related to canal, and second part is related to the water released in the field. Okay, so let's discuss the first part related to the dimension of the canal. Usually, the canals are considered rectangular, cuboidal shape. So I'll have a section of a canal and it's a cuboidal in shape. So we have to assume that it's a perfect cuboidal in shape. Now what is given in question that the depth of this canal is 1.5 meter. So this is the depth 1.5 meter deep, which we are going to consider its height, and the width of this canal is this distance. The breadth is 6 meters. Now what we don't know here is the length of this canal. So it is given that the water in this canal is flowing with the speed of, suppose this is the water, and the speed of water is 10 kilometers per hour. So we have to consider how much water is flowing in this canal in 30 minutes. Okay, suppose that the water entered at this point, or water particle or water molecule entered at this point, that travels till this point in 30 minutes. So in 30 minutes the water molecule is traveling from here to here. This means that the water collected in 30 minutes will be covering this much length. Okay, so we have to find the distance traveled by that water particle from this point to this point. That will be considered as length of this cuboidal canal. Okay, so we know that distance d is equal to speed into time. So what is speed? Speed is 10 kilometers per hour into time. Time is 30 minutes. We have to convert it into hours, so half an hour. So this will give me 5 kilometers. Okay, so we have to write this everything in detailed solution. We are just discussing the one part of the question. Okay, so I think the idea here I want to give is how much water is collected in this canal in 30 minutes. We have to find this length. This length is 5,000 meters. This is the length. So we have length, we have breadth, we have height. We will multiply them. We will get the total volume of water collected in this canal in 30 minutes. Now the second part. The water collected in this canal, this section of this canal, is released in a field. And that water is going to spread all over the field, having a thickness, a layer of 8 centimeter. Now we have to understand that area into height is volume. Okay, this thing we must know, that area into height is a volume. Suppose we have a round circular solid plane surface. This is a plane surface, and if I pour water on it, what's the volume of water collected on the surface of this plane, what we call plane surface? There is no water collected on this, because the height, there is no height to stop the water. If there is some height, the water is going to be collected. So we have the volume. So here the volume is, what is the area of this solid surface? That is the area. And if there is no height, that is height is equal to 0, so volume collected on it is 0. So area into height is the volume. Now, irrespective of this shape, it could be any irregular shape. If you pour water on it, water is not going to stay on it. So to collect water, you must raise the boundaries till some height. And you make some boundaries to collect water on it. So what is the area of this base? We cannot find the area of this irregular shape. Let the area be A. And you are raising this boundary, till height h. So what will be the volume collected? So volume will be area into height. Usually the usually the field is in form of rectangular shape. So whatever the water is collected here is released into a field, and the field are of shape of rectangular shape. Whatever the area of the base, let's not worry about it. We have its height. So area into height is the volume collected in the field. So what is the height? The height of this water is 8 centimeters. 8 centimeters. Okay. This is what I have in explanation for this question. Now we have to write everything. Okay. Now the water collected in it is transferred to a field. Let's not worry about the shape of the field. Whatever the area is this, and the water must stay on the field with a thickness of 8 centimeters. This is the layer of water, okay, on the land, on the field. We are interested in finding this A, okay, and we know that volume is equal to area into height. Okay. Now let's write the solution. Given that speed of water equal to 10 kilometers per hour, which implies distance traveled in 30 minutes is equal to speed into time. So 10 into half an hour. So 5 kilometers. So this implies length is equal to 5,000 meters. Also, height of canal is 1.5 meter and breadth of canal is 6 meter. So volume of water collected in 30 minutes in canal is equal to length into breadth into height, because it's a cuboidal shape. So what is length? Length is 5,000 and into 5 into 6. So what is it? 1.5 is 3 by 2 and 6, so this is 3, 9. So 5,000 into 9. So it is 45, 1230 centimeter cube. Okay, this is in centimeter cube. Done. Now this much water is released in field, and we don't know what's the area of that field. We know that the water must stay on the field with thickness with the layer of thickness 8 centimeter. Let's write it down. Thickness of water on the field is equal to 8 centimeter. This is in meter cube. This is in meter cube. Let's convert this into meter cube. So 0.08 meters. Let the area of field is equal to A meter square, which implies volume of water on the field is equal to area into 0.08 meter cube. Now this value and this value must match, which implies A into 0.08 equals to 45000. Okay, so A is 12308 upon 8. Now we have to divide this. Five six two five zero zero meter square is the required area of the field. I hope the explanation is clear to everyone. This is all from my side. Thank you.